cos squared theta.
Mm-hmm.
So it's just 5 cos squared theta.
And how about the last one?
2 theta over. Is it something to do with double angle formulae?
No, you could do it that way, but there's an easier way.
Um,
So go back to B for a second. So 5 times 1 minus sine squared theta. What did you do there?
yeah. So that's equal to cos squared theta.
Yeah. And so can you use that for C?
See. Well, here they're saying 1 minus sine squared 2 theta. So would that be the same as root of cos squared 2 theta again?
Mm-hmm.
And since it's all being square rooted, it would just become cos 2 theta.
Mm-hmm.
And then the whole thing is equal to tan 2 theta.
And so you have to be able to use the trig identity of sine squared theta plus cos squared theta equals 1.
Mm-hmm.
How about this?
Cos minus cos 1 minus tan. Okay. Could you just divide through cos squared theta at the beginning? Does that not work?
Okay, what would you get?
So then you get cos squared theta minus tan something. I'm not sure.
So let's not do it that way then.
No.
Another way to write this is as cos squared theta squared minus sine squared theta squared. Any idea how you can rewrite that?
Squared.
You know what? It might not even be that complicated. It might not even be that complicated. So your one was this one. So you got cos squared theta, and then basically you'll get minus sine to the 4 theta over cos squared theta. So you said that that would be tan squared theta. What would be left over?
Would that be cos squared left over? Sine squared left over.
Yeah, sine squared
Uh,
theta. We're trying to change that into 1 minus tan squared theta.
Sine. Well, you obviously the 1 could come from cos squared theta minus sine squared theta. Or no, plus. But I don't see how that could work.
You could convert sine squared theta. What could you convert that into?
1 minus cos squared theta.
Okay, so let's try expanding that. Hang on, before I take you on a wild goose chase. Minus tan squared theta plus tan squared theta cos squared theta. Okay. Let us see.
Could you
It might be what I was thinking right from the start. There's a little trick to this. Any idea what you can do with this? Another way of writing it is as squared squared.
Okay.
What is that the same as, do you know?
Cos squared squared. All I think is cos to the 4.
So that's a... How could you factorize that?
Oh, is it a plus b squared?
A plus b, a minus b.
Yeah, that's it.
So same thing for this one.
Okay, so then this would become cos theta plus sine theta.
Cos squared theta plus sine squared theta.
Mm-hmm. Times cos squared theta minus sine squared theta.
And what could you do there?
And it's still over cos squared theta.
Mm-hmm.
Could you then, divide by cos squared theta between both brackets?
Notice anything about the first bracket?
Oh, it becomes 1.
Yeah, and so it's just 1 times the other bracket. So that just stays the same.
Yeah, and then here you just divide through by cos squared theta.
Yeah. And then you get your answer. So the trick for this one is that it is squared squared. And it is the difference of 2 squares.
Yeah.
And that's not an easy one to see. But it kind of comes up, at different times. Like to the power of 4, quite often they use squared squared, so it's like a hidden quadratic. Any questions there?
No.
Okay.
Cos theta 5. Theta is reflex. What does reflex mean? Does it mean greater than 90?
Greater than 180, I believe.
Okay. So there's acute and obtuse which relate to 90, and then reflex is 180.
Yeah.
Is there an opposite to reflex?
I imagine acute is kind of the opposite of.
Okay. Greater 180. So that, and we want to find sine theta, so we can use the Pythagorean rule.
You could.
Is there another one?
Inverse cos to both sides? Arc cos?
What, to find theta?
Yeah, it might not always work. But you could do arc cos and then sine both sides.
Sure, okay. So arc cos of minus 3 over 5. Uh, 126.87. And then we sine that.
And choose answer. See how your calculator gets with that.
4 over 5.
Okay, so sometimes we get lucky. Sine theta equals 4 over 5.
And to find the other values, we can draw the graph and then just see the next point.
That's one way.
Yeah, I tend to do that because it's easier to visualize.
Okay, and okay, how about question B?
B, do that sine alpha.
Hold on. Okay, so I see what's going on. So the calculator gave us what's called the principal value, which is the value that's closest to 0. So all three, sine, cos, and tan, and if you were to draw the graphs, you would see that all three are positive. So this is our positive diagram. So it's just a summary, summarizes it down when you get a positive answer. So all three, sine, cos, and tan, are positive from 0 to 90. Only sine is positive from 90 to 180. Only tan is positive from 180 to 270. And only cos is positive from 270 to 360. They told us that cos is negative 3 over 5.
Yeah.
And it's reflex. So if it's a reflex angle, what quadrant or quadrants could it be in?
It could be in the S or the T quadrant. And since it's greater than 180, the T one.
Well, reflex means greater than 180. Yeah, you got it. So yeah, if it's reflex, then it's going to be one of the bottom two. And if cos is negative, then it has to be the tan one. And so if this angle is between 180 and 270, will sine be positive or negative?
Negative.
And so the answer we have to give is negative 4 over 5.
Okay.
So our calculator kind of helped us a bit too much. It kind of gave us the principal value when really what we're looking for is this one. And so use that idea for part B.
Okay. Sine alpha equals 2 over 5. And alpha is obtuse. So obtuse is greater than 90, right?
Yes, between 90 and 180, I believe.
Okay. So 180, find the exact value. Could we try it with the Pythagoras?
Sure.
See? Okay, so sine squared alpha plus cos squared alpha equals 1. So 1 minus sine squared alpha equals cos squared alpha. So 1 minus 2 over 5 squared equals 21 over 25.
Okay.
Which is equal to cos squared alpha. So then you take the square root of the answer, which is root 21 over 5, which equals cos alpha. And then you do arc cos on both sides.
Yep.
Which gets 20.
No. They didn't want alpha, just cos alpha.
Oh, okay. Okay. So root 21 over 5. Then would we verify that?
Sure.
So we see sine alpha equals 2 over 5. So we find alpha. So just do arc sine 2 over 5, which is 23.57. And then cos.
So I'd verify using the positive diagram. What quadrant would it be in?
So it's between 90 and 180, so the S quadrant.
Yep.
And it's a cos, so it's a minus, it'll be minus.
Yes. And so minus 4 over 5 minus root 21 over 5. So that's minus 4 over 5 minus root 21 over 5. If you're looking for a different method, I think I have one that will kind of fix your problem for you. Let's just see. So cos theta is minus 3 over 5. Using SOHCAHTOA, what is cos?
Opposite over hypotenuse.
That's fine.
Adjacent over hypotenuse.
Yes, so that's adjacent over hypotenuse, so that's minus 3 over 5. If I was to turn that into a triangle, so we have theta, this is minus 3, hypotenuse is 5. What is the opposite?
It's well, you can use Pythagoras, I guess. Root 5 squared plus 3 squared.
And so if you're to get this one, you'll use the minus type. So square root of 5 squared
Minus 3.
the
Yeah.
square of minus 3.
So the root is 25 minus 9, which is just 4.
Yep. And so using that, we have to get sine theta. What is... No, hang on. Yeah, what is sine theta from the triangle?
The sine is...
No.
sine theta.
Yeah, it's... Go on.
Sine theta is opposite over adjacent. So 4 over...
Opposite over hypotenuse?
Hypotenuse, yeah. So 4 over 5.
Hang on, 4 over 5, but we'd still have to check our diagram. Yeah, because it's supposed to be minus 4 over 5. Yeah, so it's because everything involves squaring and square rooting. So it always gets rid of the negative. And so we always just have to go back to the diagram to check.
Yeah.
So no matter what way you do it, you need to check that diagram. Okay. Any questions there?
No?
Okay. So I think I'll just use the calculator as much as possible then, and any way you're comfortable with, I think. Let me leave that for a second.
Which point are we up to on the...
If you're happy with that, I'm happy.
We could give this one a try, then move on. Or just one more example.
Yeah, actually, let me just see. That's okay. I'm looking for... That one's okay. That's a different thing. I might not have another, do I? Ah, yeah. So try part B for this.
So give that.
You use the fact, this fact from
Sine Q 2 over 3. Given that. And Q is the angle at the point Q, right?
Mm-hmm.
Yeah. Okay, so given that sine Q 2 over 3 cos Q. So we don't need to use this triangle, do we?
So we can just skip part A.
Yeah.
We just use that fact and then try part B.
So what we could do is the Pythagorean way.
Whichever way you like.
Okay. So
Try calculator.
Calculator?
Yeah.
Or what, just to find what Q is?
Yeah, and then the cos of Q.
So arc sine 2 over 3 equals 41.81. And then cos answer equals 0.745.
Is it that exactly, or
Well, it's a longer number.
So, okay, so then we have to use a different method, yeah. Whichever method you like.
So there are two methods, right? So there's the Socoterra and then there's Pythagoras.
Okay.
So sine squared Q plus cos squared Q equals 1. And then 1 minus sine squared Q equals cos squared Q. So then we do 1 minus 2 over 3 squared minus 2 squared, which is 5 over 9, which equals cos squared cubes, then we just do the root of 5 over 9. Which is, yeah, just root of 5 over 3, which equals cos q.
Is that 4 marks?
Find the exact value, and it's of q, so we verify it.
Mm-hmm.
The cost of q, so it's in the sine region, and since that's not the cos, then it's minus root 5 over 3.
That's it. Got it. Any questions there?
Nope, I get that.
Okay, that's good. So trig equations you have to be able to do. How do you solve this in the interval? All solutions.
So then, what I do is I draw a graph of sine, then I go to a half and draw a line straight through. So there are two values. So there's a half, and then you add, since this is working in degrees, I'm guessing. I'm not sure, because usually it's just adds, subtract it from 180. But I'm guessing not.
Yep.
Oh, wait, yeah. Sine theta. So you can find the first value, which is theta equals arc sine a half. Arc sine a half is 30. And then you do 180 minus 30, which is 150. And that's in the range.
That's it. How do you get the second answer for cos, do you remember?
Because you do 360 minus.
How do you get the second answer for tan?
Tan 180 plus.
Yep. Great. And so any additional answers after that would be your first answer plus or minus 360, or your second answer plus or minus 360, depending on what you need. The graph repeats every 360.
Yeah.
How do you do this one?
I was going to ask what happens when it's multiplied by 50 and then do this 5 sine x minus 2. So you do 5x equals arc sine minus 2.
Yeah.
So arc sine minus 2.
And then just 180 minus that one.
Arc sine minus 2 doesn't exist.
What was your first thing that you said, sorry?
Oh, you meant to divide by 5 first.
Yes, sorry, I thought that's what you said.
What's the case where you leave the division and stuff until the end?
That would be if it was like 3x or something.
Yeah, okay, I misunderstood. Yeah, I get that.
Okay. So maybe you're okay for this stuff then. Yeah, I think you're okay for that, just 360 minus.
Should we do some identities real quick?
Yeah, the only identity you need to do is sine squared theta plus cos squared theta is 1, according to that thing. It says double angle formulae.
Some
this might be what they're referring to about one thing. Any idea how you do this?
I'd divide by cos maybe to get tan, but I'm not 100% sure.
that's right. Divide by cos theta. And so you get tan theta equals root 3, and then you just solve that.
Yeah.
That's okay. Yes, that's fine. Let me just see that one. How would you solve question 5? So just forget all the other stuff. How would you solve it?
How would I solve it? I would make it 5 sine over cos.
Yeah, and then?
Then I would I'm not 100% sure.
So I think the difficult bit is that it is over cos, and so you would times both sides by cos.
But wouldn't that just move the problem to the other side?
Sure would, but the difficulty is the fraction.
So it becomes 5 sine x equals 9 sine x cos x.
Yes, and I can see what you were thinking. What would you do next?
Divide both sides by sine.
So that would work, and that would get you half of all the answers. The problem is when you divide by x, you lose those answers. If I was to bring these onto one side together, what could you do?
Factorize them.
Yes, and so if you factorize it, basically one bracket is what you would have gotten if you divided by sine x, and so you get sine x is 0, or the bracket is 0, and that way you solve what is in the bracket as well as this one, so you get the additional answers of 0 and 180, or whatever it is for this one. Yes, so in a case like this, instead of dividing both sides by sine x, you would factorize. Any questions about that?
No, I get that.
That one's okay. Those are okay. They're okay, so we could do one other identity one. Where did I see? I think I know what you're talking about. Let me go way back. I saw it a second ago. No. See, I think you're gonna be okay for those. It's not really identity. It's just changing it from cos theta to 1 minus sine theta, that type of thing. So these ones you don't have to do.
Is that double angle?
Oh yeah, actually that is double angle. Yeah, we do have to do them. Okay, how do you do this first one? No.
The second one is a form of double angle, right?
So did they give you an example of a function?
General ones like x to the n, polynomials.
Yeah. So what would be what does y equals e to the x look like?
It's kind of just an increasing function that passes through 1.
Yeah. And what is the range of that function?
Is the range the values of x it can hold?
That's the domain.
So then it's kind of tending towards 0 all the way up to infinity, I'm guessing.
Yes, and so basically y is greater than 0. Another way to write it would be f of x is greater than 0 because y equals f of x.
Yeah.
It's not or equal to because it doesn't reach the line. And so the domain and range are talking about the limits of it. So its limit is basically 0. The domain can be any real number, all the way to the left, all the way to the right. How about y equals 1 over x? Or sorry, what is the equation of the asymptote?
Of the asymptote,
Mm-hmm.
is it 0 in this case?
X or y?
Oh. The y one is 0.
Yeah, y equals 0. So the equation of this line is y equals 0.
Yeah.
Y equals 1 over x. What does that look like?
Is that I'm not sure.
That's this one.
Yeah.
So the domain, it would be x is any real number. What number can x not be?
0.
Yes, and so that's a limit there. And then I think the range for y is just anything, or is it? Is there a value y can't take?
0 as well.
Yeah, I think so. Y can't be 0 either, because you could rearrange that to be x equals 1 over y. Equation of the asymptotes for this one?
Would it be if it was a different function in that form, then obviously the asymptote's different. So how would the asymptotes be found?
One way would be like a transformation.
Yeah.
So at the moment, one asymptote is the same as the previous one, y equals 0.
Mm-hmm.
And so if you had 1 over x plus 1, that's a
Yeah.
transformation moving it up by 1. And so the asymptote would change to y equals 1.
Mm-hmm.
Or if it was plus 3, it would be y equals 3. If it was minus 2, y equals minus 2. What's the equation of the other asymptote?
0 as well.
Yeah.
X 0.
Y equals 0. And so similarly, if you had y equals 1 over x minus 3, that's a transformation moving a 3 to the right. And so the asymptote would be x equals 3. But the y wouldn't change.
Mm-hmm.
Yeah. Any questions about that?
No, I think I get that.
Well done. Yeah, so sorry, I have to put my little daughter to bed now. How was that for you?
Yeah, it was good. Thank you very much.
Anything in particular you want to do next time? I have that thing for the dot product if you want to.
Which thing?
You mentioned dot product last time, or scalar product.
Yeah. If it's because next time I see you, I won't need it anymore.
Okay.
But if it's like a resource or something, I'd be happy to see it if you could send it to me.
Sure, I can send it to you, but it just might not have all the answers with it, so just be aware of that. Maybe I'll just.
Oh, sure.
Yeah, okay. I'll send you the rest of things. Well. So, any idea what you want to do next time?
I'm not sure. It may be integration, further integration. So integration by parts, substitution, something like that.
Okay. So you can let me know. Any questions from me in general?
No, that's it.
Alright, well, good luck on your thing. Gregoire, let me know how you get on.
Yeah, absolutely.
And see you next time.
Thank you. Have a good week.
You too. Goodbye.
Bye.